Good morning. Good morning, everyone.
Morning. Good morning, Bob. How are you?
I'm having my coffee. I'm good. I will mute.
Can you hear me?
Heard you.
I can hear you.
Ooh, thank you. Have
Yeah,
a good day.
please mute. Thank you.
Hello, can you hear me?
Yep.
So everyone feel free to join the Jabber room and ensure you write your name in the blue sheet, which is on the Etherpad. See if you can get all that working before we start in 5 minutes time. Hi there.
Good morning. I think we'll get started now. Welcome to the six-man working group virtual interim. We're not sure if this is IETF 107, but since we didn't have a session at IETF 107, I think we will start. Assume you can hear me okay.
We can hear you.
Okay, good. Yeah, so I think we're going to try allowing the speakers to turn on their video in addition to the slides. We'll see how that works. If that's causing problems for people, we can stop doing that. Okay, Oli, next slide.
Right, so these are sort of virtual meeting notes taken from the rules that ISG gave us. This is the first of, we had scheduled 2 sessions at the IETF 107. We will see if there will be, we have just scheduled one now. We'll see, from the experience here, if there's interest in doing the other one as a virtual one as well. To get into the microphone queue, we just put the plus Q into the WebEx chat, minus Q if you want to remove yourself. And that's the only thing that the WebEx chat should be used for. Everything else goes into the Jabber room. I don't think we will do any hums or consensus taking on the mailing list. Of course, we'll have discussion and bring all the calls to the mailing list after this meeting. Please mute your microphones when you're not speaking. Remember to state your full name when you are speaking. The blue sheets go onto the Etherpad. The link is on the presentation there. It's also on the agenda in the data tracker, as well as all the materials if you want to see directly for yourself. So I think this is the first interim meeting we have in about 20 years. The last one was in Grenoble, if I remember correctly. Isn't that right, Bob?
I think that's about right, though. It's the first time we've done a virtual, one. The previous ones were all face-to-face.
That's right. And so the note well applies as it always does on IETF meetings. We have the Jabber room. I see not everyone is on it. It's very useful to be on it for this meeting, I think. So please join that if you're able to. Barbara is taking notes for us. Joel Halpin is doing Jabber scribing. The presentation link is there. And again, please sign the blue sheets. Bob.
Yes, I will go through the agenda. We're doing the introduction. Jen is doing a talk on, we're first doing the working group drafts and then 4 active internet drafts. We're going to go through Jen's creating neighbor cache entries on first up routers. Fernando is presenting the BIS document for privacy extensions. This has been in working group last call, and we're hoping to get to the point of closing that out. Then there's also the operations and maintenance and segment routing draft that's also been working group last call. And then we have 4 individual drafts, the alternate marking extension header draft, the transmission over multi-link network interfaces that Fred is presenting, improved robustness of stateless auto configuration by Fernando, and then also a problem statement regarding IP address usage also by Fernando. Any questions? Okay, Ollie, do you want to do the next one?
Yes, and that's the document status. So since the last IETF, we have published 1 RFC. That was a bit long in the tooth, so glad to get that one out the door. That's RFC 8754. which is the segment routing header for IPv6. We have two documents in the RFC editor queue. It's the ICMP limits document and the PREP64 in RA document. Suresh was very good at cleaning off his backlog before handing the baton over to our new AD, Eric Klein. So welcome, Eric. So there's nothing submitted to the ISG, nor is there anything in the IETF last call. We have two documents in working group last call, both on the agenda today. It's the privacy extensions document, RFC 4941 bis, and it's the OAM for segment routing document. We also have two working group documents currently. It's the path MTU hop by hop option, which is not on the agenda, and it's the gratuitous neighbor discovery, which is on the agenda. Yes, I think that's all from the chairs. It's just a reminder of the new document format we have. Also pointers to the GitHub experiment we're running. With regards to that GitHub experiment, we should, that's probably something we can discuss a little bit more on the mailing list now that we have gathered a little bit more information on it. So I think the next one in the queue is Jen. Do you want to come up and stand in the pink box, please?
I'm actually standing in the pink box. I am in the pink box. Can you hear me?
We can hear you perfectly fine.
Great. So, good morning. So, creating neighbor cache in the first hop routers. I am quite sure everyone has read the draft, but just in case, next slide, please. So, quick recap, in case you have forgotten about what this draft is about, actually. So, the problem statement, when hosts start sending traffic from a new address, the traffic arrives to a router. Maybe it's the same router, maybe actually another one. If you have multiple routers, that router might not have a neighbor cache entry for that address. And while the router is doing address resolution, all packets except the first one are usually dropped, which is kind of upsetting. So the proposed solution is hosts could advertise the addresses using unsolicited NAs, because apparently it's what neighbor advertisements are for. And routers might create a stale entry when they receive an unsolicited NA and there is no cache entry for that address. Next slide, please. What actually changed since last IETF when the draft was adopted? Next slide, please. So not many changes actually. Thanks for everyone who commented. Some clarification text was added regarding a destination address of such an unsolicited NAs. The current proposal is to send such NAs to all routers multicast address. The reason is, first of all, it would allow the packet to reach all routers on link, because in many scenarios, you might have multiple routers, for example, first hop redundancy, where P between them. So a router the host is usually sending traffic to might not be in the router's return flow going through. So Mark Smith made a very good comment, which added to the text that actually not increasing the multicast level significantly by doing this, because we basically are making host to send one solicited NA instead of a router sending multicast NSs to solicited multicast address to do address resolution. So basically we're replacing one multicast packet with another. Also, if the network happened to have MLD snooping configured, it's even reducing the multicast noise, because such packets will be only sent to routers, not to all hosts on link. Next slide, please. Mark also suggested that hosts might use RFC 68 and send IPv6 multicast packet as a unicast Ethernet packet, setting destination address to the router MAC address. I am not sure it's a good recommended at least solution, because again, it might mean not all routers would receive that packet, because in this case, we're basically relying on the host to know about every single router on the link. So it kind of introduces a race condition here. And as a result, asymmetric traffic case might not be covered, because if host is using router A to send traffic, and it would send such an unsolicited NA to that router, the return traffic going through another router might not be covered. Next slide, please. And the most interesting case, actually discussing potential disruption. So I spent some time trying to look into how the proposed mechanism might break something, especially in case of optimistic duplicate address detection, because in this case, basically a host might start sending traffic and sending unsolicited NAs from an address which potentially might be a duplicated one. Next slide, please. So first of all, if entry already exists on a router in any state except incomplete, no changes, right? It will be unsolicited NA with override a flag set to 0, solicited flag set to 0, so any existing entry will not be updated. So what's happened if the entry is in incomplete state? So it basically means that there is a rightful owner which is on the network, just sending traffic, return traffic just arrives, and another host, let's say host B, joins the network and starts sending unsolicited NAs before that has completed. So would it cause any disruption? Next. So what's happened normally, right, before we implement the proposed mechanism? So it will, statement draft explains, we have a kind of packet loss for period between the first packet arrives to the router and the router receives a solicited NA from a address owner. Next slide, please. So if the host with duplicated address starts sending unsolicited NAs and router updates neighbor cache entry, what happens? During that time, a new entry might be created until the rightful owner responds to a NA, right? In this case, the entry will be updated with the rightful owner MAC address. That's the reason. Basically, I do not see how traffic can be interrupted, so no changes here. That's a good news. I have not actually updated the text in the draft, but I think this scenario might be clarified a bit more, so it will be in 0.1. Next slide, please. So to summarize, in case of incomplete entry, no changes, the traffic will be restored as soon as the rightful owner responds with solicited NA. Next slide, please. The most interesting corner case is what happened if there is no any disruption happens. So after discussion on the mailing list with Pascal, I realized, yeah, the draft probably needs to be clarified. And this is actually a corner case I'd like with the group. So what happened if there's a rightful owner, let's say host A, which has an address, it hasn't been sending any or receiving any traffic through the router, so router does not have any cache entry for that address. And that host just wakes up and starts sending and receiving traffic exactly in the same moment as another host came and configured the same address in optimistic state. Next slide, please. So without unsolicited NAs creating any entries on the router, right? what happened here. Router sends multicast NS. It's basically moments when router starts dropping traffic, all packets arriving for the address A, and it creates an incomplete entry. If we have two hosts with the same address, one of them in an optimistic state, both hosts would respond, and even if the host B responded first, and it would create a reachable entry in the router, as soon as rightful owner responds, the entry will be updated, and because that NA would have override flag set to 1, and from that moment of time, the connectivity is restored, right? So it's a normal behavior, how it happens now. Next slide, please. So now everything might become slightly complicated. So let's say the unsolicited NA managed to arrive before the first packet arrives to the router. In this case, the stale entry will be created. And if that fails during the delay phase, because as soon as packet receives, the first packet arrives to the router and router's trying to send traffic, the entry will move to delay state. Because that would normally detect the failure in 1 second, right? We can expect that that failure will happen during the delay state, right? In this case, in worst case scenario, router will first send unicast NS, would not get any response from host B, then it will switch to sending multicast NS. And from moment the multicast NS is sent, we're basically going back to the original scenario. So next slide, please. The worst case scenario might be that a rightful owner might experience delay up to 8 seconds. Again, if two events happen at the same time. The owner has not been receiving any traffic through the router, so there is no cache entry, and duplicate address happened just before the traffic arrives to the router. By the way, I have a question to the audience. Do we know if any router implementations actually using the data plane traffic to move entry from delay to reachable? Next slide, please. Because in this case, it's actually quite bad scenario. Probably if the entry got into reachable state, that obviously the delay will be much longer to restore the connectivity. But I have not seen routers actually doing this. My impression is they do not actually normally watch for data plane traffic. So I'm not sure, like, is that corner case bad enough so we should not be doing this? Or it's way too many things happening at the same time, the probability is quite low. So I think, next slide, please. I think that's all I have. So yeah, as I said, I think there is one scenario when proposed mechanism might make situation worse, but on the other hand, it's quite a lot of things happening at the same time. So, yeah, so done. Questions?
So is there any questions for Jen? Seemed like a very quiet room. So we discussed this draft both on the mailing list and in the last IETF, and I think, and Bob and I have spoken about it, and I think the plan was to take this fairly quickly through the working group. So as far as we see it, we believe this is ready for a working group last call. Are there any objections to that? Do anyone see any problems taking this draft fairly quickly into working group last call? And if you have a question, just put a +Q into the WebEx chat window.
One comment. So we have basically two drafts, right? One is problem statement, one which is in V6 Ops, and another one is this one. So I not sure, but I think maybe it makes sense to have the joint last call for both of them, because honestly, I asked Fred to not go for the last call for problem statement draft in V6 ops until we go into the last call with this one, because let's say we decide that this solution is not good enough, right? So there's a problem statement draft, which actually talks about various solutions, and proposed one in particular might need to be changed. So what do you think?
Well, we could certainly last call them together. I mean, well, yeah, I guess typically the problem statement would go before the solution document. I believe we discussed as well if it was necessary to actually publish the problem statement. I mean, we can certainly talk to the V6 Ops chairs to see if we can coordinate a working group last call.
Because basically, what's happening, problem statement draft discusses various approaches to the problem, right? We can pick the router, or we can suggest the router should actually use a data plane traffic to trigger neighbor discovery, for example, right? If the router sees a data plane traffic flow from the address which it doesn't have a neighbor cache entry, it could start proactively resolution and so on. So there are various things also could be done. So I think this should be published because it explains why we suggested exactly this mechanism and not something else. And actually those drafts, so currently problem statement draft refers to this one as a normative, and this one has it as an informative reference, because I think it simplifies things. So they reference to each other.
Okay, super. We have Warren first in the queue, and then we have Fernando afterwards. Warren, please.
Thank you, Warren Kamari. I just want to sort of reiterate that this problem was originally discussed at V6 Ops. The issue was raised, and V6 Ops, the consensus seemed to be, well, that's a real issue. Let's try and fix it. No, actually, it looks like 6man's the right place to do it. So, just that V6 Ops seems very supportive of the problem.
That's good to know. Thanks a lot, Warren. Fernando, please. Fernando, go.
I was going to say that while reading this document, I should reread it, but I found that the other document in V6 Ops was quite useful as a companion to this one. So it might be useful to do the two together, or at least even if we don't, I'd like the V6 Ops one published too.
Okay, good. Yeah, okay, so I think Bob and I will take an action and to coordinate with V6 Ops, and we'll take this to the mailing list as well, obviously, but it sounds like we should go ahead and put this into working group last call.
Yeah, I'll just add one thing to this. I mean, there are lots of times in the IETF where developing requirements documents is very useful to figure out what we want to do, but they don't always get published. Because sometimes it's harder to get consensus on a requirements document than it is on an actual solution. But we will certainly talk to the V6 Ops chairs and figure out what they want to do.
And Warren will get the last word on the. No, he withdrew the microphone line, so then he will not. Then we'll move to the next presentation.
Good, thank you.
So Fernando, you are up for the 4941 BIS working group last call status, please.
Yeah, thanks. Good morning or afternoon or night or whatever applies to you. So this is a presentation about the last update to the 4941 BIS document. Next slide, please. So as a kind of recollection of the recent history of this document, of course, it's a revision of 4941. We had a working group last call starting on January 9. And so this presentation tries to summarize the recent comments and changes that have been applied to the document. Next slide. So one of the issues that was raised and was discussed on the mailing list was about concerns about the possible impact of using multiple addresses or many addresses if you want. My sense of what has been the outcome from the working group discussion is that this is an issue that is not specific of 4941, but it's a general issue of Slack. Essentially, Slack is kind of like anarchy when it comes to network configuration. So you don't really have much control as to how many addresses each node configures. So this is not really specific to 4941, but still, there was agreement that the document should say something about this. In response to the discussions that we had on the mailing list, essentially we did two things. First of all, we included specific text on this stuff in section 4. The text was circulated on the mailing list and was agreed upon with the folks that participated in the discussion at least. And another thing that we did was to reduce the valid lifetime from the previous value that was 1 month to 1 week, not 1 month, from 1 week to 2 days. And that effectively changes the number of concurrent temporary addresses to 2, okay, from the usual 7 that you'd have with a valid lifetime of 1 week. Next slide. Then there was another question about whether temporary addresses should be enabled by default or not. If you look at 4941, it says that the use of temporary addresses should be disabled by default. It gives a number of reasons for that. One is, the applications that might want long-lived connections and might fail if the addresses don't last for that long. And it also gives some mention about the possible impact on network elements. What I read as the outcome from the working group discussion, obviously not everyone agreed on this, is that it would be a bad signal for the IETF to recommend disabling a mechanism that is in some way meant to improve privacy. And in support of this, I think we have essentially 2 BCPs. First one is on privacy monitoring, and the second one is on host address availability recommendations, which essentially already says that hosts should be allowed to use addresses. Aside from that, which is recommendations that we have, even with 4941 that recommended that temporary addresses should be disabled by default. All popular IPv6 host implementations that I know of enable temporary addresses by default. That's different distributions of Linux, FreeBSD, OpenBSD, Windows, etc. Next slide. And then another one, which, if I remember correctly, this is the last one, was there was some discussion about the extent to which temporary addresses help privacy. Well, 4941 itself was called privacy extensions for IPv6 Slack. The discussion on the working group, or what I read from that, is that temporary addresses help address-based network activity correlation. Talking about privacy, it's probably imprecise if you want. And I agree with that. Even I have always thought myself that the name of the extension, to call them privacy extensions, probably wasn't the best possible title. Privacy addresses also, limit the time window during which a host is exposed via an address that is exposed as a result of active communication, meaning that if somebody knows your address, for how long they can use that address to communicate with you. Obviously, with temporary addresses, they do have a lifetime. So, eventually, even if your address becomes known, at some point it's not going to be usable anymore for that purpose. Another thing that came out as a result of the discussions of the working group is that this is a revision of 4941. So we are doing essentially is trying to address flaws in 4941. So the question, if if folks thought that that the privacy extensions or the temporary address extensions, were useless or they don't add much, well, that will be subject, for a different kind of work, like different document that target to obsolete, for example, 49.1. So what we did in response to the working group discussion, first of all, we tried to change all, or if not most of the instances of the word privacy, and try to focus on what temporary addresses achieve. And this also includes the title. So rather than keeping the title privacy extensions to IPv6 LAC, we changed it to temporary address extensions, which is more precise, I would say. And we try to clarify, throughout the document, whenever there was a use of the word privacy, try to change it to temporary addresses, and try to focus on what the document is doing, because at times saying privacy might mean different things for different people. I also set different expectations. So that's something that we did. Next slide. So in the last 1 or 2 months, we published 2 revisions of this draft. Revision 07 was meant to address the working group last call comments. If I remember correctly, the first working chair's revision. And we recently published revision 08 was meant to address the second working chair's review. So as authors, I guess our question is if there are any further comments, and if not, is ready to ship for publication.
Super, thank you, Fernando. So please join the microphone queue if you have any comments. I think the fundamental question here is, do people feel that their last call comments have been addressed sufficiently? And if so, I believe this should be ready to ship. We'll confirm that on the mailing list, but this is your chance to come and state if you don't believe that's the case.
Yeah, and I noticed there's some comments in the Jabber room, so if you could put yourself in the queue.
So, Alexander, you are first, please.
Yes, hello, this is Alexander Petrescu. Thank you for the opportunity to be in the queue. And so a very brief comment. Is this privacy about the address or about the interface ID? Question.
You might be on mute, Fernando, if you, at least we can't hear you if you're responding.
Okay, sorry. Can you hear me now?
Yes, we can hear you.
Okay, cool. So I will try to, stay away from the word privacy, and I would say that, so first of all, this document is about addresses, not interface IDs. The two are related, but they are not, they're not necessarily the same thing. So this document is about the use of temporary addresses. Of course, the interface IDs are not predictable. Otherwise, you get privacy addresses if you want. But as I noted during the presentation, I think it's better to try to stay away from the word privacy, because that means different things for different people. So I think it's let's say better all these temporary addresses. What these addresses do is, or what this document does is, specify a mechanism that allows implementations to produce temporary addresses, addresses that obviously have a limited lifetime. That's it. That is supposed to help with based or address-based network activity correlation and other stuff. But I prefer to not use the word privacy because I don't think it leads to more disagreement that it should.
Yes, if I may reply, thank you for the comment. Yes, indeed, privacy itself has many different interpretations, and okay. So my comment was whether this document has a mechanism to design privacy for IIDs, basically randomizing them. But that is probably useless if it's always the same prefix and it's always the prefix length 64. But I know this comment is this relationship to the PLN is a stretch. So that is all I wanted to say. Thank you for the.
Thank you, Alexander. And
sorry, this was discussed, and of course there are like even in the document itself, it's noted that it tends to help, and it helps better in specific scenarios, like if there are multiple systems on the same subnetwork. In any case, even if, for example, you have a single node in the same subnet, you always use the same interface identifier. Then I can right away, and without giving any further analysis, assume that two different communications correspond to the same system. Now, if I am changing the interface IDs, even if I am the only guy on the subnet, at least the guy doing the network activity correlation has to do assumptions that, for example, in that case, I'm the only folk on the subnet. So it's not as as trivial or as right away as it would be without the temporary addresses. But anyway, as I said, I think it's better to talk about this as what it does. Like it specifies a mechanism for producing temporary addresses, and as such, the consequences are these, or the implications are these, as opposed to talk about privacy, because that's a much broader topic. That's what the last revision 08 has tried to address. And if I understood where it's coming from, I think that's where some of the comments from Oli to do.
yeah, and we have one more question from Logan. By the way, Fernando, can you come a little bit closer to the microphone and turn up your gain a little bit? That would be good. But Logan, please.
Mine is more of a comment.
I believe we should be ready to ship this advance this document to our new AD. Okay, thank you, Fernando. Then Zafar, you are up next to stand in the pink box. Please say next when you want me to advance the slides.
Hi, can you hear me well?
We can hear you well.
Oh, great, thank you. So I'm going to cover SRv6 updates, basically all the updates that are through last call for this document on behalf of my authors, co-authors, as well as, next slide, please. Contributors. Next slide, please. So here's a bit of history of the draft. The work started almost close to 3 years ago. There has been 11 revision of the draft since the individual submission. The working group call started on December 4, 2019. We are using a GitHub where we've been posting incremental changes and communicating on the mailing list. There has been 17 commits to the GitHub repository during this. We promoted them in 2 different rounds. One was version 3, and then one was version 4, where we took the last repository and posted revision 4. There has been active discussion of this draft on the mailing list. I would like to thank all the folks that have contributed and have provided comments. Next slide, please. So in the next few slides, we are going to go over summary of comments and as well as what changes were made in the draft to address those comments. So first one is we removed the TLV section. There were comments from Ron Bonica, the first mail in this list. The next mail is pointed to mail from Greg. And the third one is pointed to mail from Zen Quing. And basically, their question was that if the draft doesn't have a use case illustration for TLV, then why do we have this section? And authors agreed, and we removed the TLV section. The next comment was regarding illustration for O-flag processing. So this is some comments that were around some clarification needed for the O-flag processing. The first in this list is a comment is a mail from Joel Harper, and the next one is discussion that happened with Greg. What we did is we added an illustration section for O-flag processing that essentially illustrates and focuses on a controller-based passive O&M use case. The illustration is created such that we cover both nodes that support O-flag as well as SRv6 nodes or endpoints that do not support O-flag because O-flag is optional, and also non-SRv6 capable nodes that are on transit. So it is orchestrated such that we can make it clear to the reader on how O-flag is to be used. And then the next one is the ICMP error reporting section. That was a comment from Zhang Qing. And the comment was this, that if there is no change to the base ICMP v6, then what is the point of reporting it in this draft? So we removed that. Obviously, the draft relies on the base ICMP v6 processing as without any change. So there was no need as such, and this section has been removed. The next row is really about adding normative text for the O&M process that had been mentioned. These comments, among other people, there was comment from Joel Harper and Ron Bonica, where they were asking for what happens. We need some normative text on what happens when packet is given to the O&M process. And what we did is we added some normative text of that nature. The rest of the details are implementation specifics, and we point that out as well in the draft very clearly. And this is how we address these comments. The last row in this table is regarding the discussion that happened on the n.otp SID, where the reference is from email conversation with Joel Harper, Greg Minisky, and many others. And the point was this again, that since the draft does not have use case for this specified, it is better to move it to a place where the use case would be specified. So we removed the n.otp SID as to address that comment. And next slide, please. So then now the next set of comments are mostly for clarification text that was needed and were asked for. The first row here is on the scope of O flag for passive O&M. Essentially, there was a comment like how the passive O&M is, how the O flag is used, and there was confusion in terms of the scope and all. So we did clarify that, all of that, that passive O flag is used for passive O&M, and that lead to the next set of questions that Greg and other has on the mailing list. Is that what is the relationship of this passive O&M with in-situ O&M work that is going on? And essentially, the point there was that we added text. In short, the point is that in-situ O&M carries the metadata that is related with the packet in the packet itself.
Safar, do you want to take a question? We have Joel and Greg in the microphone queue.
Okay. Do you prefer that we go over this and then we take question, open the floor, or you prefer we take it now?
Well, if you why don't you finish this slide and then we go through?
I think it may be better that I go over and then we take a question.
Sure.
So we were on the relationship between in-situ O&M and the passive O&M by O flag, and passive O&M by O flag is a controller-based O&M where copies of the packet is sent to a controller for correlation, where in-situ O&M is a mechanism where the O&M data actually go in the packet itself. So that is the difference, and that has been very clearly clarified, both through illustration as well as through normative text or non-normative text. The next set of questions, which is the row number 3 here, is there were discussion with respect to O&M consideration, if there is any with PSP sits, and the answer to that was there is no special consideration needed to handle PSP sits. This has been clarified on the mailing list. There was a discussion with Joel Harper, Brian Carpenter, Greg, and others. So that clarification text is now in the draft. Last but not the least on this list is the comment that we received from Lua Anderson, and that was about there was clearly missing entry for INA consideration for O flag registry. That was gladly added to the draft. Next slide, please. And then the next set of questions are related with editorial changes. So Lua Anderson provided a very detailed review with approximately 36 comments. We have addressed all of them, and those has been acted by Lua. There are 2 comments that are pending, and they are listed as to be done item in the next slide. But many thanks, Lua, for such a detailed review. Is greatly appreciated. Then we had very detailed review from Zhang Kuang as well, and these comments, what the comments were also in this review. It doesn't mean that they're only editorial. There were other comments as well that are addressed as either clarification text or substantial changes. But here is that there were additional comments that were related to editorial changes, and those are addressed. And that same apply with comments that we received from Ron Bonica, and they have there were some editorial changes requested. Those changes have been made. There was a detailed review done by a Min, and those detailed reviews have been responded back. Min has responded back on the list on 1 pending item, and that would be addressed as well. There were editorial comments in Greg emails as well, and those comments have been addressed. There were editorial comments from Brian Carpenter as well, and those are addressed. There are other miscellaneous comments as well from other folks, and they have been addressed. This list is not exhaustive. Next slide, please. So on the pending changes, like I mentioned, Lua had detailed review with 36 comments. There are 2 comments that are pending that will that requires adding more substance to introduction and abstract. So they would be editorial in nature, and then changing notations for interface addresses that are used, and that would be editorial in nature. So we have, we acknowledge that these 2 comments have been not addressed, and we do plan to address them very shortly. Then Bob Hendon kindly had comments on the XML file, send priority to the author. And these are, again, issues with the XML file. We do acknowledge that we have not get chance to address them, but we will address them gladly. None of these comments will require any substantial or normative change to the document. Next slide, please.
Do you want to take questions on these ones now, Safar, before we move on to those 2 last ones? Joel Halpin, do you want to go first, please?
Please. You said that you had added illustrations of OBIT processing to address my comment. And you added illustrations, but that doesn't address my basic problem with the description of the OBIT processing. The description describes something that is entirely internal to the device and does not describe the actual behavior that must be performed. The description says, must make a copy, send to control with a timestamp. Well, that's not an external observable. That's not something we standardize at all. The question that that the document needs to address is, what does the router actually have to do with a packet that has the OBIT set? Sending to control is not what the router actually has to do with the packet.
Okay, so there is a pseudocode that is a normative need for what device is supposed to do. How device implement that is really an implementation matter. We
But
did
the
add
pseudocode, no, but Zafar, the pseudocode you have there is entirely about internal behavior. It is not about what is the external result of the OBIT. You cannot require a device to make a copy of a packet because you can't tell if the device made a copy of the packet, which is what the pseudocode says. That's not an external observable.
when a device
Do not normatively specify internal behavior.
when a device advertises that it can support OBIT, then it's externally known that it will do this operation. That it will make a copy for telemetry operation. It will make a copy of the packet for telemetry operation. Now, how?
That's not a meaningful thing to do. I have a real basic problem with this document because of this.
Can I ask a question, Joel? Could you propose some text on the list, how this could be resolved?
I actually do not know what they intend to do. This is really a case of I can't propose text because I do not know what the expected behavior is. The behavior described is not the externally observable behavior.
You look at the illustration. The
illustration is not the normative definition. I'm looking at 511 O flag processing. One nice thing about this, I'm looking at it as we talk. You say it illustrates it, but you haven't defined what the required behavior of the device is.
So I think
a copy is an internal operation.
There is a pseudocode which is a normative behavior.
No, the pseudocode you have here is an entirely internal behavior. What is the external normative behavior? What is it that is required to be done externally visibly?
There is also additional text on externally visible elements that talks about telemetry, the copy of this packet, which is externally visible, what is expected from it. And that gets complemented with the illustration. I think what would be good is if you can have a look on the illustration section. We'll be happy to have another call as well with you or discussion to give
I have looked
clarification.
at your illustrations that they do not tell me normatively what you expect the device to do. And I'm sorry, Bob, I understand that normally send text is the appropriate response. But when I don't know what the document is actually telling me to do, I have a problem. And I have a very basic problem. My rule for this stuff is always, if this is approved as an RFC, is this something I can implement? I do not know what to tell my implementers to implement from this.
Yeah, but they are implemented. They have implemented this with this information. So, but I mean, Joel, this has been implemented. So anyway, I think the point is that is okay. We can. We are happy to talk with you. Even set up a WebEx call to come to a text explain, and then come to an understanding of what you are expecting. Because what is not clear to us is what you are expecting beyond, above and beyond what is in the document. We have external behavior, we have internal pseudocode, we have illustration. Let's work together to see how we can document it to a satisfaction. Does that sound like a
I'm
good
happy to talk to you further, but I had raised this multiple times and you have not dealt with it. Fine. I do not think it can progress until this is solved. This is very, very basic to the function of the document.
That is.
Sounds like this is something we have to take to the list. I mean, if there are other people who also, see Joel's point, I'm sure it would be helpful if they could also try to express it, differently, so we can see, so we can get some help figuring out, what's missing here in the description of the old flag. But I think we have to take it to the list.
I'm happy to take it to the list. I'm happy to have conversation by phone or WebEx or whatever.
Yeah, let's do that.
The illustrations do not resolve the problem.
I mean, the author would be really happy to work with you on this.
So we have Greg and Ron in the microphone queue. Greg Mirsky, please.
Yes, thank you. I apologize, I didn't get a chance to read the latest version, so I cannot say what this changes. I want to make two comments. First, I think that your interpretation of OEM classification based on RFC 7799 and O flag as a passive OEM is incorrect, because you're using this and you're modifying the packet so it would be a hybrid OEM. Second, I still believe that what you try to achieve with the O-bit is achievable with the current IOM or in situ OEM, because the work on in situ OEM continues in IPPM working group, and currently now we have what's called as direct export function, which achieves the same thing that you try to make happen with the O flag, as I understand. So I would still want to continue our discussion on what's the difference between using O flag and using IOM approach. And I would appreciate to be part of a discussion on a topic that Joel brought up, because I do have my concerns there as well. Again, before their new text, but I'll read the text and I'll comment to the list. So that's probably it.
Yeah. So first of all, Greg, many thanks. So regarding whether this is really a passive ONM or a hybrid, we can definitely talk. This is terminology thing, one way or the other. The point regarding how it is differ from any of the IONM work. So here the motivation is to get these data from only segment endpoints, because these are the nodes that are very well suited for information. They're very well suited points in the network for traffic engineering. So rather than overburdening network with all the information, they provide key information. So, so that is one aspect that we can certainly talk a little bit more with you on this, Greg, and we'll set up a call as well, like that we discussed the normative text that we talked about with Joel as well with you, and address your comment.
Thank you. And we have Ron in the queue. Could you have the last word, please, Ron?
Okay. Quick question about pinging a SID. Let me make sure I understand the mechanism correctly. Say for a minute, you're not pinging, you're just sending a packet to a SID, and the packet traverses the IGP least cost. So you just send an IPv6 packet. Destination addresses that SID. There's no SRH involved at all. Now you decide that you want to ping the SID. So you would have to include an SRH so that the first SID in the path would be the end OT, and the second one would be the SID you're pinging. I have that right?
Yes, go ahead.
What's bothering me is that the data plane traffic has no SRH in it, and the OAM traffic has an SRH in it. The presence of the SRH may actually change the result. For instance, if somebody's filtering packets with extension headers, the ping won't get through when in fact the data packet will.
Yes, I think that's a fair comment, Ron.
How do we fix this?
We need to, I think we'll take this comment. This was not raised in the list prior. We'll take this comment and we'll contact you.
Okay,
You can take it on the mailing list, or we're taking notes here. We will for sure come back to this.
Okay, sounds good.
Thank you, Ron.
Okay, so far that was the microphone queue. So if you want to run quickly through the rest of the slide, that would be great. We're a little short on this one.
So essentially, with respect to the deployment, implementation, interoperability, there are 6 known deployments of the draft in production network, and there are additional undisclosed deployment. There are implementation status as well that is noted in the deployment draft, which is mentioned as a source on this page. So you can have a look on all the deployments for this draft, because it just talk about this, but there are 12 platforms that have shipping code with this, including OFLAG. Now, with respect to interoperability, they were interop done at EANTC in 2019. There was as well a multi-vendor interop done in MPS World Congress, or showcased at World Congress, and there are authors are aware of interoperability testing between vendors that were privately done. So all this information is publicly disclosed, except the private details on the SRC deployment status draft. Next slide, please. So we will, as we mentioned, we will address all the pending comments, the comment discussion that happened today. We would like folks to review revision 4, send any additional comment on the mailing list, or you can reach us. One question for the chairs is that maybe it's a good opportunity to explain to the group the expected usage of the GitHub, because that's what we've been using. But it would be good to get that clarified, because I think there was some confusion during the use of GitHub, both from authors as well as from the working group.
Right. So yeah, this is Ole. So I was the one who's been trying to push for the use of GitHub here. with somewhat mixed results. The intention was to focus the working group more on the document itself and actual text changes. So what I was hoping was that the reviewers would put in pull requests for individual issues as they found them. Those pull requests in GitHub would then gather a consensus or not, and then the document shepherd would press the commit button on those changes, just like we do with source code. And then if there were the discussions on the issues themselves would happen on the mailing list. You could have that discussion on GitHub as well, but it sort of discussions quickly diverge from sort of the text itself. So it seemed like they would do better on the mailing list, but it has been so far I don't think we have seen any pull requests. So this is sort of back to the IETF mantra of proposed text. If you want changes, propose text, and if you have text, please do them as pull requests. But that's pretty much as far as it goes, and it is an experiment. You're free to propose text in the mailing list with old and new, as we have done. You're marking them as old and new, as we have done in the past as well. Yeah, that's pretty much it. Was it anything else you wanted clarification on so far?
No, that sounds good to me. We found that uploading a version on GitHub incremental changes is very efficient. So I think that's from the experience, that would be the feedback. And we'll continue to use it. Because it's always, this change has been addressed in GitHub, have a look at there, and then we can promote a few versions on a timely basis. So I think it is.
I mean, the hope was really that we sort of built working group consensus around each pull requests and committed that, and by the end of it would be no sort of unresolved issues when the revision came out and everyone was aware of what changes were made. I don't think we've quite gotten to that point yet, but at least we sort of experimenting with the tool to see if it does help us as a group of people trying to do sort of collaborative editing on a document. But we'll see. But thanks a lot so far for the
thank you very much
update. I think we need a new revision, right? That's at least clear. So this finishes the working group documents. The next one is Giuseppe on the IPv6 application of the alternate marking method. That's a individual document. Giuseppe, are you ready?
Yes, can you hear me?
We can hear you well. Go ahead.
Okay, good. Yeah, hello everybody. This is Giuseppe. I'm one of the co-author of this draft. This is an update of the IPv6 application for the alternate marking method. Okay, next. Yeah, just to give a quick recap about the methodology. So maybe, I don't know how many people is already familiar with this methodology. I hope most of the folks. Anyway, the alternate marking methodology is a NOAM performance measurement technique. In particular, it can be classified as hybrid or also passive, depending on point of view. The reference documents are RFC 8321 and also the multi-point altmark draft that is in RFC editor Q. So the basic idea is to batch the packets by switching the value of a single bit. In this way, we can group the packets and count the packet loss along a path. And in addition to packet loss, it's possible to measure also the delay. In particular, in single marking methodology, we can measure first and last packet delay of a group of packets, or also average delay. If we want more informative packet delay metrics, it's better to use a second bit for marking. So it's the suggested and the most suitable way is to use 2-bit, so the so-called double marking. Next. Yeah, what about IPv6? So why we are proposing this draft? The main requirement for the application of this methodology is the marking field. So since we need a marking field, we have to identify it. And in particular, we already worked on a draft that analyzed the different alternatives the marking field. And in the end, the best choice was the use of an option header that can be both op-by-op or destination, depending on which kind of performance measurement we want to enable. In summary, the alternate marking application is very straightforward and very simple because it does not affect the packet behavior. Just the source node, only the source node writes the option header to mark alternatively the flow. And both the intermediate nodes and the ending nodes may be configured to support this option header or not, but this does not impact the traffic and the measurement, since the measurement can be done only for the nodes that have this option enabled, while for the other nodes, simply the metric is not done, but nothing happened. In the end, the alternate marking methods allow both op-by-op and end-to-end measurement. So next. The better way to apply this methodology is to generalize the alternate marking data fields. And so a new TLD, we want to introduce this new TLD to be encoded in an option header. We follow the option header format, and you can see the red box, the generalized data fields. So we add to the two marking fields, the loss bit and the delay bit. We add also a flow monitoring identification. This is required for some general reason and for deployment experience. In particular, this flow identification helps to reduce the per node configuration. So helps to reduce, for example, the number of access lists on the router that we need to select the flow. It simplifies also the counters handling, especially in tunneling and so on. So to avoid deep packet inspection, to find the right encapsulation and so on. And also it eases the data export and correlate the collect. While we also identify the first 3 bits of the option type, because as also I mentioned before, we need 3 0 values because this option can be skipped if it not recognized and data don't change en route. Only the source node set the marking bits. Next. Okay, as encapsulation header option, we can have different alternatives that we can evaluate. For example, if we use this option header as destination option, the measurement can be done only by the node in destination address. As op-by-op option is the best way because every router on the path with this feature enabled can make the measurement. There is also, we also mentioned the option of the SRH TLV, but in this case, every node that is an in the SRH, in the SR path can do the measurement. And the same behavior can be obtained with the destination option together with the SRH. In this case, also every node that is an entity can make the measurement. Anyway, we clarified also after some discussion on the mailing list, we clarified that the usage of the SRH TLV is still under discussion within the community. So it's not the preferred solution for now. And in general, hop-by-hop and destination option are the most suitable ways to implement alternate marking because it's valid for IPv6 in general, including also the subcase of SRH. Next. From the 0.1 version, so we got several comments on mailing list from Bob, Paul, Tom, Stefano, and Brian. And thanks for raising the discussion. And, as I said, these fruitful feedbacks help to clarify better the scope of our draft, to help to analyze how to encode the TLV for alternate marking application, also adjust the wording somewhere and update the references. We also added the definition of 3 high-order bits of the option type in the very last version, and a new co-author has joined, maybe some version before. So I think we are, next slide will be the last one. Yeah, as a next step, yeah, we think that we have found an agreed way to apply alternate marking and also its extension that is in RFC Editor Q. And the authors consider the draft ready for working group adoption. So anyway, we are open to questions, comments, and.
Okay, excellent. Thank you, Giuseppe. Eric, no, sorry, Ron, you are first in the queue.
Okay, first, I do think this is an interesting experiment. I'd like to note a couple things. First, it's based upon RFC 8321 and draft PPM Altmark, both experimental or informational or experimental.
Ron, you're dropping a bit, at least from my side. Would you try to be
sorry.
to the microphone and speak up a bit?
Sorry.
Thank you.
I'll be a little louder. Both of these documents that this draft is based on are experimental or targeted for experimental. Another thing is there are some security issues that remain to be worked out. I think it might be a good idea to progress this document as experimental, and at least for the time being, use experimental code points for the option identifiers.
Regarding your first point, yeah, you are right. Both RFC 8321 and multi-point Altmark draft are experimental. There was also some discussion, in particular during the AD review of the multi-point Altmark draft, about the scope. They Miria suggest to change into informational, but anyway, experimental and informational, nothing changed. So we can consider borderline between experimental and informational, but anyway.
Would be interesting.
Regarding,
I'm sorry, go ahead.
yeah, and anyway, this is not the main purpose here. So the idea is to, because both RFC 8321 and multi-point mark draft are more focused on the methodology that is general. So if you want to make, since to apply this methodology, we need space in the packet header. We cannot make RFC 321 and the other one and the multi-point draft as standards, because we cannot standardize nothing, because we are just talking about a methodology that is transport agnostic. So it can be applied to IPv6, to beer. We also have a draft in beer that is standard track, because it applied the RFC 8321 to the beer, to the multicast traffic. And it is following the standards track, because in that case, in the beer, we are asking for 2 bits to implement and to encode the alternate marking application. And it is basically the same thing that we're trying to do with IPv6. So we aim to define bits, and also we have defined a generalized field to encode the alternate marking application and to make it standard, in order to go beyond the experimental, that is the experiment that is described in the RFC 8321. So that is just to explain you the motivation.
It's not clear to me that that experiment has concluded yet. Would you be averse to using experimental code points until it concludes?
It's not an experimental code. So the methodologies is, I think, is already completed. I mean, the basic methodology is already completed, and it is applicable if you look at both RFC 8321 and also the new coming RFC. It's well completed from all the point of view, because it investigated all the aspects of the deployability of these methodologies. But the only things that we need to deploy is the space in the packet header. Otherwise, we cannot deploy this methodology. There are already experimental deployments, both in Telecom Italia network and also as a Huawei product, and also in other products that are presented that are already deployed. But anyway, to make it applicable and standard, we need to follow the standard track, in my opinion, in order to clearly define the field that can be used to apply these methods.
Okay, thanks for that, Giuseppe. That's a discussion I think we have to continue the status on this document and on the list. I have Eric Vank and then Eric Klein. Eric, please go.
Thank you, Ole. This is Eric Vank here without any hat here. First, Giuseppe, thank you so much for the document. As a side note, I really wonder whether it's really not a waste to spend a complete extension header just to transport 2 bits, but okay, side apart. I really wonder, my real question is about using the hop-by-hop extension header in this case. Typically measurement, my understanding, are done end-to-end. And in order, if you're using hop-by-hop, it means that every router on the path will have to have a huge amount of scalability issue, because it needs to remember all those measurements compared to the end-to-end. And I'm pretty sure as well that you know that hop-by-hop extension headers are still quite drop a lot over the internet. This header is a little bit better on this. Any comments on this?
Yes. Yeah, I know that hop-by-hop options is not we can say recommended, but in RFC ATT 8200, it is also stated that in case there is a strong motivation for the usage of hop-by-hop, it can be defined. But apart of that, you can consider that the intermediate nodes don't need to read the option header, and so they don't need to handle or modify the content of the option header. So maybe this can be easily managed by the router instead of other kind of option header when you have to put information. In this case, you just need to read the marking that is set by the source node. So this.
But even if you read, it means that the CPU sees it, Giuseppe. And again, there's version -01, so that's open for discussion, of course. We may want to continue this on the list, but just pay attention on this. And again, good work.
Yeah.
Thank you. And Eric Klein, you get the last word on this draft.
Thank you, Eric Klein. No hats, sort of similar to Eric's comment. Actually, I was wondering with respect to hop-by-hop or a hop-by-hop versus destination option, whether or not there was value in having both, that you might use destination for sort of just end-to-end measurements, and you might, if you say wanted to do something across your own network, if you were running a multi-continent wide backbone network, and you wanted to trial some stuff, you could use the hop-by-hop options.
Yes, it's correct.
Both options.
Yeah, it's correct, because the scope of the draft is to define the general TLV, the general option that can be encoded both as op by op and also with the destination option, of course. Yeah. And also, I also mentioned the case of HTRV, but it will be maybe in the future if it will be used. But for now, we can focus on both op by op and destination option, of course. Yeah.
Yeah, I guess that I was trying, there's lots of text about hop by hop or destination, and it was not clear if you were attempting to choose just one or leaving the option open for having the same format for both options.
Yeah, the idea is to leave the choice to the implementers. Maybe it's better. Maybe also if the draft will be adopted, we can continue the analysis and together with the working group to understand what are the limitations for each kind of deployment and so on. So that is the idea, to for now to leave both options open for the implementation, and then we'll see. Yeah.
Thanks very much.
Thank you, Giuseppe. Fred Templin, please step up in the pink box.
Yes, I'm on now. Do you hear me okay?
We hear you perfectly fine. Go ahead. Thank you.
Okay. Okay, so this is a document titled Transmission of IPv6 Packets over Overlay Multi-Link Network or Omni Interfaces. Let's go to the next chart, please. So in terms of agenda for this talk, I'm going to give some background and motivation, the mobile node mobility service architecture model, the Omni interface model itself. I'll be discussing about the maximum transmission unit, link local addresses, a new option called the Omni option, router discovery and registration, the conceptual multi-link selection algorithm, and then state the document next. Let's go to the next chart. Okay, background. The International Civil Aviation Organization is designing a worldwide IPv6 based aeronautical telecommunications network with Internet Protocol services. It's going to be known as the AT IPS. Each aircraft mobile node is assigned a unique mobile network prefix from an aggregated mobility service prefix by the Mobility Service Prefix Authority. For example, ICAO would be the authority for the mobility service prefix for the ATN IPS. So if the MSP is a /32, then /56 MNPs can be assigned, and then the aircraft acts as a mobile IPv6 network. Aircraft that connect to the ATN IPS via multiple air-to-ground wireless data links, and these data links often have diverse properties. Some examples are VDL Mode 2, LDAX, SATCOM, Aeromax, and there will be others. So we need an air-to-ground interface for multi-link coordination, and that's what this document is about. And again, the document is titled Transmission of IPv6 Packets over Overlay Multi-Link Network Interfaces. We've received substantial review input both from the ICAO working groups and from IETF members, and they've resulted in significant improvements. And the draft has been reissued with alignment to the 6-man working group. And members of the ICAO Communications Panel Working Group by Mobility Subgroup have issued a 4-action liaison statement on 329 requesting standards track publication. Next chart, please. Okay, now I want to talk about the overall architecture for mobile nodes in the ATN IPS. So on the right diagram, you see a block of a mobile node in the upper portion of the diagram, and it has multiple access network link connections. Over those access network link connections, the mobile node sends native IPv6 packets, and they are received by an access router that connects that access network to the rest of the global worldwide aeronautical telecommunications network. So we have native IPv6 packets on the access network interfaces. The access router serves a proxy between the access network and the global internetwork. So the access router performs encapsulation on its INET interfaces on behalf of the mobile network acting as a proxy. Within the mobility service that in the worldwide interconnected internet network, there are mobility service endpoints that support distributed mobility management. In particular, each mobility service endpoint tracks a subset of all mobile networks in the global INET. Okay, let's go to the next chart. And what I want to do now is to look in more detail at the architecture of this mobile node that we had in the previous diagram. The mobile node has a virtual interface known as the Omni interface. And that's the mobile node's virtual interface connection configured over multiple diverse underlying ANET interfaces. So again, they would be SATCOM, LDAX, Aeromax would be examples of these interfaces. The Omni interface assigns an IPv6 link local address known as the Omni link local address, and that's used for neighbor discovery messaging. And the access network interfaces are unnumbered interfaces underneath the Omni interface. So there's no IP address assigned to the connected access network interfaces. And the Omni interface is the mobile node's logical attachment to what's known as the Omni link, which observes the non-broadcast modal access link model. The Omni link incorporates the mobility service and spans the worldwide internet network. Again, in this case, the ATN IPS for air traffic management. Next chart, please. Okay, maximum transmission unit. We are saying that the Omni interface maximum transmission unit is 9,180 bytes. That number came for RFC 2492, but there was a string of earlier RFCs where that number was motivated from, and that's the number that we're going to be using for the Omni interface. So only the Omni interface MTU is exposed to the IPv6 layer, while the underlying ANET interfaces may have a wide variety of diverse MTUs that could be smaller than 9180. For example, 1280, 1400, 1500, etc. The traditional approach, when an IPv6 packet comes into the Omni interface, it would drop the packet that was too large for a selected underlying interface and return an internally generated packet too big. But we want to do better than that. So we have a new approach where within the Omni interface, we'll perform link local RFC 2473 encapsulation, IPv6 and IPv6 encapsulation. Then apply IPv6 fragmentation to the ANET interface MTU size. The link local destination then gets to reassembly, and it can optionally return advisory packet too bigs if reassembly becomes problematic. This provides us with lossless path MTU discovery. The source is going to dynamically adjust to any advisory packet too big messages with no loss. And it supports sizes up to 9 KB gigabit Ethernet jumbo frames across any access network link type. So the number of 9180 is not the size of the physical data link units underneath. What it is the size that the receiver needs to be able to reassemble. Next chart, please. So the Omni interface assigns Omni link local addresses. And the way that we form link local addresses for the Omni interface is that we take the aircraft's mobile network prefix, or the mobile node's mobile network prefix, and we embed the prefix within the interface ID of the link local prefix FE80::/64. So for example, for the mobile network prefix 2001 DB8 1000 2000, the corresponding Omni link local address is FE80::2001 DB8 1000 2000. Omni compatible mobile node IPv4 compatible mobile node Omni LLAs are assigned from FE80::FFFF::V4 adder. So for example, for IPv4 address 192.0.2.1, the Omni link local address is FE80::FFFF:192.0.2.1. So that's for mobile nodes. The mobility service assigns link local addresses from the prefix FE80:/96. So those addresses would be FE80::1, 2, 3, etc., up to FEFFFFF. The IPv6 link local subnet router anycast address is already defined in RFC 4291 as FE80::. So that's used as defined in RFC 4291. And we reserve a block of future use addresses, FE80::FFFF through all Fs. So this is under the assumption of the /64 prefix length. If the IPv6 addressing architecture changes to permit future prefix lengths of 65 or longer, the Omni link local address format is going to be able to accommodate up to /118. So that provides us future proofing in case we get to the point where we have prefixes longer than /64. Chart, please. Now the Omni interface is going to be using a new IPv6 neighbor discovery option type called the Omni option. It's going to appear in IPv6 neighbor discovery messages. We need a new type to be defined by IANA. And the Omni option header includes a prefix length and R flag to be used for source address based prefix registration. So for example, in an RS message, if the source address was FE80::2001 DB812, again, this would be an OmniLink local address. If the prefix length was 56 and R1 meaning to register, then the mobility service will register the mobile network prefix 2001 DB812/56 in the routing system. You can think of this as a stripped down version of prefix delegation, because all we're trying to do is register the prefix in the routing system. Since the mobile node already knows its prefix, all it's asking to do is for the mobility service to register the prefix in the routing system. And then within the Omni option, there is a list of sub options that follows that has multi-link and mobility service parameters. And you can see below the format of the sub options and the currently defined sub options that we have, PAD1, PAD-N. I've indexed tuples of two different types, mobility service register and mobility service release. Next chart, please. So the Omni option includes what we call IF index tuples. And there's type 1 and type 2 IF index tuples. Both types include an IF index that identifies the underlying access network interface, an IF type, which is the type of the ANET interface, very similar to the way IF index and IF type are used in network management. Provider ID is set to the access network service provider, and then we have a link quality metric, with 1 being the lowest, 15 being the highest. 0 means that the link is down. Type 1 IF index tuples include a vector of 2-bit preference values. Preference values 0 through 63 correspond to the 64 IP differentiated service code points. P64 and above are additional traffic selectors. They could be based on application port numbers, IP address ranges, etc. And each P value includes a 2-bit value, 321, meaning high, medium, or lower disabled, for this particular IF index. And then we have a type 2 IF index tuple, which includes an RFC 6088 format traffic selector. And this could be used for flow binding encodings in IPv6 neighbor discovery messages without requiring adjunct mobility messages. Next chart, please. So then router discovery prefix registration using the Omni interface. What happens is that the mobile node will send router solicitation messages with Omni options. And they'll be sent over individual ANET interfaces that are configured underneath the Omni interface. When the access router receives the router solicitation, it notices the Omni option and then coordinates with the mobility service. The access router then returns router advertisements with the Omni option and any auto configuration information that would normally be delivered in a solicited router advertisement message. So what the mobile node does is it sends initial router solicitations to register its mobile network prefix and an initial set of up ANET interfaces. So for example, if the VDL mode 2 is up, you send a router solicitation over the VDL mode 2. If the SATCOM is up, you send a router solicitation message over the SATCOM, etc. So the RS messages are sent from within the Omni interface over an up underlying ANET interface, and the process is coordinated from within the Omni interface, and it's opaque to the IPv6 layer. So all this is going on below the IPv6 layer. The access router processes the RS message and conveys the Omni option information to the mobility service. The mobility service injects the mobile network prefix into the routing system, caches the prefix length and mobile network prefix and IFA index tuples, and then the mobility service directs the access router to return the router advertisement message to the mobile node, again with an Omni option, and with non-zero router lifetime if the prefix registration was successful, otherwise zero. The mobile node receives the RA confirmation, and then the access router will be set to forward packets between the mobile node and the mobility service. Next chart, please. Next chart, please. Thank you. So after the initial registration, when an ANET interface transitions to up, the mobile node sends an Omni RS message. When an interface transitions to down, the mobile node can send an unsolicited neighbor advertisement message over any up ANET interfaces with an IF index tuple for the down interface with link set to 0. So for example, if my VDL mode 2 goes down, I send a UNA over the SATCOM. The mobility service gets it and then takes the VDL mode 2 link out of its selection process for traffic selection. The mobile node departs from a current mobility service endpoint. It can send an RS or UNA over any up ANET interface to release that mobility service endpoint. When the mobile node associates with the new mobility service endpoint, it sends a RS or RA over any up interface with a mobility service register. Now, one thing that's interesting about this is that when we have multiple mobility service endpoints servicing the same mobile node, the RS or an RA message can include multiple register IDs in a single RS message. So I could send a single RS message over, for example, my VDL mode 2 link, and it would register with multiple mobility service endpoints with a single message. And that amounts to a very large saving of messages over low data rate access network links. So then finally, when all the mobile nodes underlying interfaces have transitioned to down, or if the prefix registration lifetime is expired, the mobility service withdraws the mobile network prefix from the routing system. Start, please. So now that all of this has been set up because of all the RSRA messaging.
Fred, can you, we're sort of running out of time here. I wonder if you could go to the next slide and then allow for some discussion.
Certainly, we can skip ahead to that one. Thanks, Mom.
Thanks.
So really what we need to talk about now is the status of this document and next steps. This document has been a work in progress in working group by the mobility subgroup of ICAO since March of 2019. And it's now published as an IETF internet draft. There's the draft name. We have code that's in advanced stage of development and testing in Linux-based network emulations and early aviation testbed trials. Also other relevant trials such as enterprise network mobile devices. And in our liaison statement, we've requested the IETF to adopt the work. It's an example of an IPv6 over foo spec. It uses a new IPv6 neighbor discovery option known as the Omni option that needs to be standardized. And it uses a new link local address format known as the Omni link local address format. And we're requesting standard track RFC publication. So for what we're asking from 6man is for additional review input, and if co-authors would be interested, and also asking 6man to adopt the work as a 6man working group item. And now I'll break for questions. Thank you.
Okay, so we have one question from Alexander. Alexander, please go.
Yes, hello, Fred. How are you? Okay. Yeah, so I have several questions. Some are more detailed, some are higher level. and I have put them in the Jabber for reference. I suspect there is not enough time to discuss them all now, but this LLA, the LLA format or Omni on the Omni interface looks like a link local address that integrates in its interface ID part the mobile network prefix. And an example is given on slide number 7 with a mobile network prefix that fits well because it has a prefix of maximum 4 hextets, or you said 56-bit. But it is a good thing it is not a 64, so it is 56. But could the mobile network prefix also could it be more like more than 64, for example, 5 hextets?
So Alexander, done is we've said that for prefix lengths up to /64, those prefix bits will go into the 64-bit interface identifier of FE80::/64. For prefix lengths longer than 64, the additional prefix bits would begin to be encoded in bits 10 through 63 of the IPv6 link local address. So what this allows us to do is in the future, if we were going to allow prefixes longer than 64, those prefix bits would appear in bits 10 through 63. Since the addressing architecture has FE80::/10, that allows us to encode up to a /118 prefix.
Okay, perfect. Thank you very much. That's all from me.
Eric Klein, you're next, and then we have Esther Silva last, and then we have to move on. Eric, please.
Yeah, Eric Klein. No hats. Thank you, Fred. I think, okay, let's set aside FE80::/10 because I think there are some issues there, right? By convention, it's 60. This /64 that's available on the link, but I guess you're going to say this is different for this particular link. But I had a question about, like, if we set aside the MTU reassembly, the MTU, the link-specific variable MTU and reassembly issue, is there any reason this couldn't just be a regular router with the /56 assigned to internal addresses and doing link local communications on each link, moving this forwarding plane from interface to interface separately?
So you're asking whether the virtual interface model can be lifted and just expose the underlying access network interfaces to the IPv6 layer instead. Is that your question?
Assuming the MTU reassembly issue could be punted to the lower layer, yeah.
So there are slides beyond my backups here that I don't think we have time to go into, Eric. I'd like to ask you to go to those charts and look at what they're talking about in terms of the advantages and the rationale for having the virtual interface. Some of the points that will be included there are things like the fact that you don't have to get care of addresses, if you will, the access network interfaces if you use the virtual interface. So that means that since you don't need to get, well, I'm going to be going into an exhaustive list if I start, but I'd like to direct you to those charts, and if you could take the discussion to the mailing list on that.
There was some of this was being able to register connectivity over links where you, like on slide 11, where you would seem to lose some fate sharing. But you know, there's no like you seem to indicate that you could register connectivity over links without actually sending packets over them. But there's a certain fate sharing about being able to to make sure the link is up that you can communicate over it and register via it. But perhaps like I said, I'll read your backup slides and I'll read the doc. Thanks.
Thank you.
So Esther Silva, please state your name and you're next and last in the queue. Thank you.
Thanks, Alisalo from IKEA, actually. Just a question, Fred. It's a simple question, actually. What is the relationship between the Omni interface and the existing mobility solutions like MIPv6 or Lisp? Do you have anything about that?
So I think the background about our discussions in ICAO are not widely known to the IETF, Sala, but I'll just mention that we are looking at multiple mobility service solutions for the aeronautical telecommunications network within our protocol service. And two that you mentioned are two of the solutions that are being proposed. But the Omni interface is tended to be and is generic to whatever the mobility solution would happen to be that is chosen for the ATN IPS. It's strictly the air-to-ground interface, and the mobility solution would then be triggered by the air-to-ground interface messaging. And there's not any favoritism given to any of the mobility solution candidates. This is meant to be a generic interface.
Thanks, Fred.
Bob, do you want to say something more on this draft before we move on?
Yes, thank you. Yeah, so I think this is all very interesting. I'm pleased to see this work being, brought to the IETF. I think there's a lot of work. The liaison is sort of a work in progress at the moment. But the one thing that I would personally like to see is that some more or at least more justification to understand why there's a lot of things here which are not well beyond an IPv6 over foo spec. It's proposing new ND options, a bunch of things. And I'd like to see more justification for why those things are necessary, why it's sort of, I think to Eric's question, why can't IPv6 just be used as currently defined? What is the benefit here? It's adding a lot of complexity. I realize this is for a particular subdomain, but I think there's going to need to be a lot of discussion over some of these issues. But we will do that on the list. Thank you.
Okay, thanks a lot, Fred. We are 7 minutes before our ending time. If people don't mind running a little over, we might do that. Fernando has asked to swap his last two slides, I think. Is that correct, Fernando? You want this one first?
No. Just hi Oli. Keep the other one. What I meant is that if we run out of time, I prefer to do this one with appropriate time, and just postpone the other one so that we don't rush.
Let's try and see if we can do both. We'll see how much time this one takes, and we'll decide. And
okay, cool.
Yeah, go ahead.
Okay, so this is a presentation about improving the reaction of IPv6 Slack to flash renumbering events. This is a topic that has been discussed a lot, both on the 6-man mailing list and on the B6Ops mailing list. Next slide. So essentially, there are a lot of different scenarios. Some are more common than others. In which you might have a host connected to a network, and all out of the sudden, network configuration changes, or somehow the router just vanishes. On the left-hand side, we have a very common scenario in which we have a CPE router that is doing prefix delegation with the ISP, and at the same time is doing Slack on the home network. And one of the scenarios that might happen, and that is common, is that, for example, the CPE router crashes, reboots, and it gets a different prefix list from the ISP. In most cases, the CPE router just doesn't record on stable storage the prefix that was listed before. So when the router reboots, it has no knowledge of the previous prefix that was listed. It starts advertising a new prefix on the local network, and all the nodes on the local network, all the hosts, keep the stale information. There are many different scenarios in which this kind of thing can happen. As I have mentioned on the 6-man mailing list, we have a B6Ops working group item that discusses the problem in detail. So this presentation and the corresponding draft, they focus on the protocol updates that will be necessary to improve Slack's response to renumbering events. But the problem statement and the problem itself is discussed in detail in a B6Ops working group item. Next slide. So when considering protocol updates that would be necessary or would be valuable to improve the reaction of Slack to renumbering events, there are a number of things that or a number of aspects that are interesting to consider. First one is about signaling. For example, we have two options in some scenarios. The router itself that trigger the renumbering event continues operation. It may be aware of the stale information, or it might be unaware of the stale information. For example, in one case, the router crashes, reboots, but the router had stored on stable storage the information about the prefix being announced. So the router rebooted. It now got a different prefix list from the ISP, but it's aware that the information has changed. So it's somehow in the position of trying to deprecate that information. In other cases, the router might be unaware of the stale information. That would be the case, for example, if the router reboots, gets a different prefix, but the router doesn't record on stable storage the prefixes that are listed by the ISP. In other cases, we could have, for example, the router just disappear. For example, the router just crashed, or for example, a switchboard was moved to a different VLAN. So we had a router that was advertising information, and just that router somehow disappeared. Whether because the router itself disappeared, or because, for example, as I mentioned, a switchboard was moved to a different VLAN. Another thing to consider is where we might, apply improvements. So you can apply improvements on the host side or on the router side. If you apply the improvements on the host side, then that means that in order for hosts to benefit from these improvements, they don't need for the routers to be updated, and that's that's of course valuable. On the other hand, if we apply improvements on the router side, that means that even if we have host implementations that have not been updated and improved, then they can nevertheless react better way, in a time-layer way to these renumbering events. So what our draft tries to do is to pursue improvements in all of these areas. Both on the host side and also on the router side. But we think that the host side improvements are particularly valuable because as soon as you implement them, then no matter whether the routers have been updated or not, they can already react in a better way to these next slide. So I'll try to summarize the improvements that we are proposing in these next few slides. So if you look at the current specification for Slack, it specifies a preferred lifetime for prefix information options of 1 week. The slide says 1 day, but that's incorrect. So the current default preferred lifetime is of 1 week. The default valid lifetime is of 1 month. Of course, that's the equivalent of setting timers that will never go off in any meaningful time. Okay. So what our document proposes is, on one hand, to change the default lifetime for prefix information options and routers, and select or set this lifetime as a function of the router lifetime. Currently, what we propose is to set the preferred lifetime of prefix information options to the router lifetime and set the valid lifetime as a function of that. If I remember correctly, we set it to n times the router lifetime, and we currently set n to 48. That means that with the default value for the router lifetime, we'd use a preferred lifetime of half an hour, and we'd use a valid lifetime of we reduce the preferred lifetime from 1 week to half an hour, and we reduce the valid lifetime from 1 month to 1 day. On the other hand, we also propose to cap the received lifetime at host. Of course, this is useful when your host is connected to a network and the local router is still using the default values currently specified in RFC 4861, if I remember correctly. So our document proposes to cap the preferred lifetime, the router lifetime, and cap the valid lifetime to n multiplied for the router lifetime. Currently, that would mean capping the valid lifetime to 1 day. So that means if the advertised lifetimes are longer than that, then we reduce those lifetimes. This means, for example, when it comes to the host side improvement, that even if the router, for example, disappears, the host can recover in a later manner. Next slide. Then there is another issue. If you look at section 5.5.3, item E of RFC 4861, it essentially prevents the valid lifetime in a PIO from reducing the valid lifetime associated with the corresponding addresses to anything smaller than 2 hours. That means that if you receive, for example, a PIO with a valid lifetime of 0, the receiving host is expected to ignore that PIO. This is, if I understand correctly, this was specified in this way for security reasons, but from our point of view, doesn't make much sense to just prevent these PIO or to specify the PIOs to be ignored, because from the point of view of an attacker, if an attacker wanted to just implement for example a denial of service attack, it has like a zillion other attack vectors, like for example flood hosts with bogus PIOs or route information, spoof router advertisements with a lifetime of 0, so the router itself is disabled, etc., etc., etc. So from our point of view, it boils down to either you implement first hop security or you don't, because if you don't, the attacker has so many different attack vectors that it has other options other than sending PIOs with a valid lifetime of 0. And on the other hand, if you prevent hosts from reacting to PIOs that have a valid lifetime smaller than 2 hours, then you prevent like a time layer reaction to renumbering events in situations in which the local router is aware that network configuration information. Next slide. And finally, we also specify a couple of alternative algorithms. They are meant to do the same thing, so I'm just going to describe one of them, but the other one is very, very similar. And the idea is for hosts to actually try to infer when network configuration information has changed. For example, this would be the scenario in which, for example, a router crashes, reboots, it gets a different prefix list from the ISP and starts advertising this new prefix. Now, if the router has not recorded the previous prefix on stable storage, it will start announcing a new prefix for auto configuration, but obviously at the same time, it will cease advertising the previous prefix. So the idea is simple. From the host point of view, if you see that the same router that was advertising a previous prefix has ceased advertising that prefix and has started advertising a new prefix, that should be taken as an indication that network configuration information has changed. So what we do is essentially try to implement that, like try to deprecate the stale prefixes upon receipt of router advertisements from the same router, but RAs that cease to advertise the previous prefixes. And as a kind of improvement to the algorithm, we try to unfold the processing of ULAs and the ULAs and the processes of global prefixes. So what the algorithm does is this: if you receive a router advertisement from the same router as before, the router that was advertising a previous prefix, the RA advertises a new prefix, but it's missing the previous prefix. Then what you do is you reduce the preferred lifetime and the valid lifetime for that previous prefix. What we currently do is reduce the preferred lifetime in the order of a few seconds, just to accommodate the theoretical scenario in which the configuration information might be split into multiple router advertisements. And we reduce the valid lifetime. If I remember correctly, we reduce it to the order of about half an hour, or maybe even 1 day. Obviously, the valid lifetime is reduced to much longer. And we do the same thing for ULAs. If you receive a prefix that is advertising a ULA, but it doesn't advertise the previous ULA, then you reduce the preferred lifetime and the valid lifetimes accordingly. At the same time, if the prefix was being advertised by multiple routers, then you essentially disassociate this prefix with this specific router. We are talking here about the cases where we are having scenarios where the network is using multiple prefixes. And in summary, this algorithm is able to deprecate prefixes when a new prefix is being offered by the same router, but the same router has ceased to advertise the same prefix. Put another way, if the same router from which we got the configuration information is now advertising a different prefix and is not advertising the previous one, we try to reduce the lifetime values so that these prefixes get deprecated in a time layer manner. Next slide. Implementations. So lately we have been working on implementations of these things. We did implementations for a number of daemons which are used in different operating systems. So this slide tries to summarize existing implementations. When it comes to reducing the lifetime values that are employed by router implementations, we implemented this in different daemons. RAD, which is the daemon employed by OpenBSD. RADBT, which is the daemon employed in Linux normally. And we have an ongoing implementation for RTADB, which is the daemon employed for FreeBSD.
So Fernando, since we're running over, I wonder if we should start on the microphone queue now.
Yeah. At the end of the day, there are multiple implementations of this. They are summarized in this slide. So please move on.
Fantastic. So we have Jen, Philip, and the Erics. Jen, do you want to start? You wanted.
I wanted no, the previous one, I guess, about lifetime equal router lifetime. Yes. So sorry, I haven't properly read the latest version of the draft, but does it mean if I am draining one of my routers and the router advertises 0 lifetime, the PIO will get 0 preferred lifetime and 0 valid lifetime? It will get immediately deprecated and became invalid, which might be actually very undesirable behavior.
If your router is the only router that is advertising this prefix, yeah, that would be the case.
Okay, so if two routers advertise the same prefix and the host is getting an array with 0 router lifetime, you're still not deprecating the prefix, right?
Exactly.
So, but does it mean like the router will be advertising the preferred lifetime of 0 in the PIO?
That would mean by default. So what we did, for example, in the implementations that we have, is if you are not setting the preferred lifetime explicitly,
yeah,
the default should be to advertise the same lifetime as you do for the router lifetime.
Yeah, I think it's kind of dangerous for default behavior. Let's say I have a router, I have two routers, and I'm going to drain one, and I didn't specify explicitly lifetime in configuration. So now the first router advertises it will put 0 PIO preferred lifetime, which will indicate to host, oh, please deprecate the prefix. I think you should be very careful about dealing with 0 lifetime in arrays, 0 router lifetime in arrays. What router shall put there?
Okay, I mean, to be honest, I'm not sure if we had considered that specific case, but I mean, point taken, and we'll take this into account into the next revision.
Thanks.
Thank you. And Philip.
Okay, so first a general comment. I think this is an important thing that should be solved, and certainly changes on the host would help to solve this quickly, because it will take forever for all the routers to get updated. The thing that has me worried about is the inferring stale information thing. It seems that the algorithms that Fernando is working on are fragile, are not reactive. Since I introduced the issue with if you alternate normal global user unique address in ULAs, now the algorithm has become more complex because it has to do separate processing for ULAs. But even then, it's not clear if we should build in just one type of ULA into a host and then later be stuck if we want to have another ULA-like concept and then find out that it's going to fail. So I think that that's part of the draft. It really needs a lot of work and needs a different way of approaching those algorithms, because this doesn't seem to work to me. So that's my comment.
Yep. Thanks a lot, Philip. I think that's a very important comment. We have to ensure that we end up with not a less robust protocol coming out of this. I think we should, all work together and thoroughly look at the protocol implications here. So thanks a lot. So you have the Erics. So Belgian Eric first.
Oh, and by the way, the WebEx was scheduled to end at 45 minutes after the hour. I'm not sure what will happen. We'll find out in about a minute. So if it dies, it dies.
Okay. So WebEx will cut me off. Okay. Hello, Fernando. This is Eric Vank here. Also on slide 6, it's typical for router advertisement to be sent multiple times by the router, because all the messages and all the options in the router advertisement can be longer than a single array. So it could be common that one PIO is sent in router advertisement 1 and another PIO is sent in router advertisement number 2. So different router advertisement from the same router. Furthermore, there's also a possibility that, and it's quite common nowadays, that unsolicited multicasted arrays are not sent every minute or so. They are sent much longer, meaning that the frequency is much higher, simply because we want to reduce the numbers of multicast array. So basically the assumption where you buy this algorithm is maybe need to be reviewed, right? PIO are sent differently, but from the same routers in different arrays, and array frequency is much lower than you expect.
Actually, the two algorithms do consider this. Like, for example, both algorithms consider like all of the options might not be included in the same message. That's why, for example, in this algorithm that is described in this slide, we don't set the preferred lifetime to 0 right away, but we set it to, in this case, to 5 seconds, because we are assuming that if the router is splitting the information into multiple arrays, then that time of 5 seconds accounts for the receipt of those different arrays, for example.
But in this case, in the case of the multicast array, you can miss it over Wi-Fi. There's another issue, right? Multicast over Wi-Fi, you are lost.
That's correct, and there are two things. Like essentially, you can accommodate for to those cases by setting these two values. The preferred lifetime that you set the PIO to, and the lifetime that you set the valid lifetime you set to. So in this case, you could say that the 5 seconds is more aggressive. Now, if you wanted to accommodate, for example, to other cases, like, when the options are split into multiple messages and the packets are lost, etc., 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 these lifetimes could be increased.
Okay, and then kind of defeating the purpose of your draft. Anyway, we need to work on this. That's basically my point. Just if you're aware about this normal multicast and PIO sent from the same route and different arrays, then we can work on this further.
I would say that I check myself, and I also I check with team, and I haven't seen myself any case where they are actually sent in multiple different arrays. Again, obviously there's a trade-off. If you can react more aggressively or not.
But my understanding is that your draft is basically a host behavior, not a router behavior. So you cannot infer. Whatever. We want to
Okay.
go offline.
I think we have one last comment from Richard Patterson. Please go, and then we'll end.
Still on the same topic, really. I think I was going to reiterate Fernando's, I guess, view on how the PIOs are generally seen in the same array, but whilst it is supported, it could be in separate ones. But also we could look at triggering router solicits, perhaps including the PIO option in the solicit as a bit more of a, I guess, a reactive approach as opposed to just decrementing the timers. Something to look at, maybe.
Yeah. We definitely have to continue this on the list, I think, and do some thorough reviews and discussions on this. I think that has been very useful. Bob, do you want to yeah, we'll run our time, so we'll skip Fernando's second sessions. We have to do that on the mailing list. But Bob, do you want to say the farewells and summary?
Yes, so thank you. Yeah, so thanks for everyone for joining. Oli and I will talk about whether we want to schedule a second interim meeting. I think this generally worked pretty well. We could do the talk we didn't get to today, and then there were some other things we had queued up for IETF 107 that obviously haven't happened. So we'll be back in touch on that. I think the WebEx in general worked pretty well. So wish you all, everyone be safe and well. We're living through some very interesting times that I think we'll all remember for a long time. So thank you very much and take care.
And next time we'll promise to do a hum.
Thank you, guys.
Take care, everyone.
Okay, bye.